All right, ladies and gentlemen, today we're advancing. Today we're going to be factoring when A is not 1. So that means A has a value. Positives or negatives, doesn't matter, but it has a value. So let's see what we have going on here. So remember, standard form ax squared plus bx plus c. Everything you've seen thus far, A has a value of 1. So it makes it a little more simplistic. So I'm going to have you write down the steps first, and then I'll walk you through what those steps look like. So step 1 is to factor out a GCF, if there is one. Sometimes there's an extra GCF that's hanging out there, so sometimes you got to take that out. The next thing you're going to do is you're going to draw your box, which is something that's going to look familiar to you, and and the X puzzle. Oops, that did not. Okay. Then we're going to fill in our first and last terms. Again, you're just writing these steps down for now. Then we set up our X puzzle. We solve the X puzzle. We fill in the factors on the table, and we'll look at that here in a minute. Then we find the GCF in a column or a row. And again, we'll look at that in a second. And then we check by multiplying. Okay, so let's see what we have going on here. So this is the X puzzle here. On the top, we have the multiplication. So this would be A times C. And then in the bottom of the X would be the sum. So this would be just the B value, okay? And then, of course, we would have two factors here and here. So we'll look at what that looks like here in just a moment. So here's an example. We use this one to walk through. Here are all our steps. So the first thing we're going to do is factor out any GCF if there is one. I'm going to go ahead and say there is not one. So we're good there. I've already drawn the box in the X puzzle. And now we're going to fill in the first and last terms. So our first term will go here, 3x squared, and the last term will go here, so plus 1. Okay. Then we're going to set up our X puzzle by multiplying the first and last terms. So here, this would be 3 times 1. So that means this would be 3. Okay. Then we have -4 for the sum. Now I'm going to solve my X puzzle. So I need factors of 3 that will give me a sum of -4. So this is where integer rules come into play. So I need a positive solution. So I could have 1 and 3, or I could have -1 and -3. So if I need a sum that's negative, what makes the most sense here? This one here, correct? So we know we're going to have factors of -1 and -3. So now that I know my two factors, I'm going to go ahead and fill those in here. So this would be -1x, and I'm going to leave the 1 there for now, just for setup purposes. And then this is a -3x. So now basically what we've done here is we've set up if we were to multiply two binomials. So now we have to go backwards. So what I'm going to do is look at the rows. I want to factor out the greatest common factor from 3x squared and -3x. So we can go back to this idea. You don't have to do this every time, but when I list my factors, this would be 3 times x, and this would be 3 times x, and there's a -1 there too. But my common factor here would be 3x. So 3x would come hang out front. The next thing I'm going to do is look at that denominator, that bottom row. If you notice, I have -1x and just 1. So it looks like a +1 would be the best thing to come out of that. Now we're going to do the columns. So if I already have 3x, that means this column has to be x, because 3x times x gives us the 3x squared. And again, because I already have 3x, this one would have to be -1. Now, I'm going to look at what I have here. If I were to multiply these two guys, I wouldn't get a +1, nor would I get the -1 I'm looking for here. So that means I have to do some reconnaissance here and fix something. It looks like this guy right here actually needs to be negative. Oops, let me switch colors here so it looks better. So this one actually needs to be negative. So then my two binomials would be x minus 1 and 3x minus 1. So if I go to multiply this and check, I would have 3x squared minus x minus 3x plus 1. So then my like terms here would be 3x squared, -4x, and plus 1. And that gets me what I need. So looking at our solution here, this guy right here would be our two binomials. A little tricky, I know, but sometimes this is why we do a lot of our math in pencil and things like that. So let's try some more. Again, this is one of those things, and I say this often about things in algebra, the more you practice, the better and the easier it's going to get. I'm going to draw my box in the next puzzle, done it. Then I'm going to fill in the, okay, so set up my X puzzle. Now I'm going to, all right, so I'm going to look at a greatest common factor. There isn't one. Then I'm going first and last terms. So here, this would be 2x squared, and this would be a -21. Now I'm going to set up my X puzzle. -21 times 2 would be -42. Remember, this is A times C. Excuse me. And then in the denominator, I have -1. So that means I need a product that's negative and a sum that's negative. So think about those integer rules and what that means. Of this X puzzle. So we're actually going to list our factors for -42. Now I'm going to just do 42 and then we can talk about the signs. So 1 and 42, it's not going to get us what we need. How about 2 and 21? Nowhere near 1. 3 I don't believe is a factor. 4, what about 6 and 7? If I look at that, that could give me what I'm looking for. But now we have to talk about the signs, because I need a sum, I need this negative. That means the larger value needs to be negative. So that means we would have -7 and a +6. So when I go to fill in my table, I would have a -7x and a +6x. So now let's see what we can do as far as factoring out our greatest common factor. So I'm going to start with the first row. It looks like my greatest common factor is a 2x. In the denominator, it looks like I can factor out a 7. Now, I want to talk about this. Both of these terms are negative. We have negative signs here. So I'm going to make this 7 a negative because that'll help us out in the long run. Now I'm going to go to my column. If I already have 2x and I need 2x squared, that means this needs to be an x. And -7 times x is -7x. So far this works. And for that second one, I'm going to do, let's say, +3, right? Because 2 times 3 is 6. looks good. So when I take those out and I have x plus 3 and 2x minus 7, I'm going to multiply. X times 2x would be 2x squared. X times negative 7 would be negative 7x plus 6x minus 21. When I go to combine my like terms, I have 2x squared minus x minus 21. That's exactly what we need it to be. So then that would be our solution right here. Sorry, that yellow is not the best. All right, here's another one. I look at this one and I say they're all even. That means I can factor out a 2. So when I do that, I'm going to pull out a 2, and then whatever's left stays as part of the trinomial. So I would pull out a 2. So what's left, if I divide by 2 here, this is 3x squared. This becomes 4x, and then this becomes 1. So if you notice, this is going to make our lives a lot easier. Rather than dealing with 6, 8, and 2, now we have 3, 4, and 1. All right, I have my x. I have my box. Let's set up our x puzzle. 3 times 1 is 3, and my sum is 4. I'm also going to fill in my first and last terms. Oops, not 6x. We're using the one we created. This would be 3x squared, and then this would be plus 1. I went too far here. So now we need factors of 3. That'll give us a sum of 4, so we're looking at 1 and 4. So we have a plus 1 and a plus 4. So then my two terms would be x and positive 4x. So we'll put this as a positive 1. All right, now we can do greatest common factor of the rows or the columns. The good thing is everything is positive here, so we know that both of these are going to end up positive, which is nice. So let's do the greatest common factor of, let's do a column this time. So in this case, this column, looks like the only thing I can factor out here is an x. And as out of the second one, it would have to be a plus 1, wouldn't it? Now let's look at the rows. Oh my goodness, I messed up here. This should be a 3, so should this. Wow. All right, that didn't change much, just that number there. Okay, so I guess I got a little ahead of myself there. So that means here I would have to factor out a 3x. And then that means down below, the only thing I can pull out of that one is just a 1. So we would have 3x plus 1 and x plus 1. Let's see what we have here. So 3x squared plus 3x plus 1x, and I'm just leaving the 1 there for us to not lose track, and then plus 1, combining my two like terms. Now, remember, we have this 2 that we factored out, so that 2 comes into play. So this 2 needs to actually be brought down here. So we would really have that 2 hanging out front. Oops, here. So to recap, we have 2 times 3x plus 1 times x plus 1. This is where we are. I'm sorry it's so messy. Let's do one more. All right. I don't have a greatest common factor because 19 is prime, so I don't have to worry about that. I have my box, my x puzzle. I'm going to fill in my first and last terms. I'm going to set up my x puzzle. 12 times 4 is 48. And then I need a sum of negative 19. So this is going to be a little bit tricky. Now, because my sum is positive and I need a difference, when we talk about those two binomials, It looks like we're going to need one of each. Okay, so when we're done, we should be looking for that. Now, let's go ahead and solve. So I need factors of 48 that will give us a sum of 19. So I'm going to start with the obvious. We have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8, and I think that should be it. So if I'm looking for a sum to be negative, that means both values, actually both values need to be negative. I got ahead of myself there. So that means it looks like we're talking this pair right here. So we have a -3 and a -16. So when I go to put this here, I have -3x, -16x. So, greatest common factor. Let's do the first row. So when I look at my first row, my greatest common factor looks like it's going to be a 4x. And of the column, remember they both need to be negative, so we're going to take out a -3. So now we're going to work backwards. If I already have 4x here, what do I need to have up here? X. And then we already decided this is going to be negative, so 4x times -4 will give us -16x, so that works. And then -4 times -3 is a +12. So there we go. So we have x minus 4 and 4x minus 3. Let's check this bad boy out. So we have 4x squared minus 3x minus 16x plus 12. Combining my middle terms, I have -19x, which is really the main focus here. So we are golden. Going through the motions, ladies and gentlemen.